This theorem is about the congruence of right-angled triangles, and it states that if two right-angled triangles have equal hypotenuses and the arm of one of the triangles is equal to the arm of the other, then the two triangles are congruent. So what this means is that we have these two right-angled triangles, and we know that their hypotenuses are equal, plus we know that one of their sides are also equal. So this means that the two triangles are congruent, and you can assume that they're congruent without even going through the trouble of trying to measure the third side. So how do we prove this? Well, let's have these two triangles, ABC and DEF, and we want to prove that triangle ABC is congruent to triangle DEF. And let's assume that we already know that side AB is equal to DF, which are the hypotenuses of both the right angle triangles, and also let's say side AC is equal to EF. So to conduct the proof, first we're going to move the triangle DEF next to triangle ABC so that the side that we assume are equal, AC and EF, can lie upon one another. And once we do that, we get the situation. So because we know that AC and EF are equal, we see that they fit perfectly on top of one another. Plus, we know from before that the hypotenuses of both the right angle triangles are equal. So that means that triangle ABD, the new triangle that we created, has to be equal, since AB and DF or AD are equal. Now, because we know that it's an isosceles triangle, that means that line AC is the altitude of triangle ABD, since it forms two right angles along. We see that since there's two right angles here, that means this line is perpendicular, forming the altitude or the height line of triangle ABD. Thus, we can say that this is the altitude of our triangle, but that also means that point C here is the midpoint of BD, and that's because in an isosceles triangle, the altitude and the median line are the same line. And you can see the proof of that in another video. So since it's an isosceles triangle and we know this is the altitude and the median, and we know that C is the midpoint, which makes C the midpoint, then that makes this line BC equal to the length of this line DC. And that shows by side, that this triangle, this right angle triangle, is congruent to this right angle triangle. So now we've shown that as long as we know that the hypotenuse and one of the sides are equal to the hypotenuse and the other side of a right angle triangle, then you can automatically assume that two of the right angle triangles are congruent.